to confusion matrix. So all of you are requested to bring calculator, keep pen and note ready with you, and you have to do lot of calculation and you have to reply as I am going to ask about the calculations which you have to carry out. So please move fast. So this is confusion matrix. All of you are aware in classification, the output is always in terms of actual versus predicted. So rows are your actual. This is 2 cross 2 matrix, right? Same way you can have a 3 cross 3, 4 cross 4, and you can have n cross n. So actual means whatever it is there in your table, right? Whatever it is present in your data, and predicted means predicted by class, predicted by specific classifier like neural network or Naive Bayesian, whatever you are using. So whether actual and predicted both are same or different, right? So all of you are aware, if it is same, it is perfect classification. If it is not same, then it's a misclassification. So prepare this confusion matrix. This is a general template of confusion matrix, right? So rows are actual, columns are predicted, right? So my class, 2 classes are there, yes and no, and this is also yes and no. So how many of yes I am actually saying? System is also saying yes, right? So this is yes to yes, then yes to no. I am saying yes, system is saying no. I am saying no, system is also saying no. I am saying no, system saying yes, right? So 4 combination is there: yes, 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 no, 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 and no, yes. And based on that, I am saying this as A, B, C, and D. Okay, and this A is called true positive. So I am saying from my side true and false, and positive and negative from system side. So there are 4 combination: true positive, false negative, false positive, true negative. And my accuracy is, there are 2 class yes and class no. So this cross diagonal, right? This divided by all 4 value. TP plus TN divided by TP plus FN plus TN plus FP. This is how you can calculate accuracy of any classifier. And the word is confusion matrix, right? The confusion is where you have a misclassification. This is my actual classification. A to A, right? That is yes to yes and no to no. Apart from this cross diagonal, these values are misclassification. This is a confusion. That's why the name of the matrix is a confusion matrix. So please remember all this: TP, FN, TN, FP. Right, so these are the limitation of accuracy, and that's why some additional measures are required. So let us consider 2 class problem, okay? And the number of class 0 has 9990 example, and number of class 1 has 10 example. And if model predicts everything to be class 0, then your accuracy is 9990 divided by 9990 plus 10, that is 10,000. So it is 99.9%. But this accuracy is misleading because model does not detect any class 1 example. So let us see all this, you will understand. Chalo, this all are the things, means all definitions are also important and all equations are also important. Means you have to remember formula also as well as this definition also. So what is called accuracy? Accuracy is nothing but the overall effectiveness of the classifier, right? So whether the classifier is effective and how much it is effective, it is called accuracy. It is TP plus TN divided by all four values. Then we have a precision, right? So let us say precision is TP upon TP plus FP. TP upon TP plus FP. So this first value divided by the sum of this first column. TP upon TP plus FP. So this is what is your first column. So precision is what? It is a class agreement of the data labels with the positive labels given by the classifier. So precision is nothing but how many positive labels are given by the classifier. Then we have a recall. It is also called sensitivity, right? This is called effectiveness of a classifier to identify the positive labels. So it is TP upon TP plus FN. TP upon TP plus FN. So it is first value divided by the sum of first row. Okay, TP upon TP plus FN. So it is called a recall or sensitivity. So these all values are to be calculated from confusion matrix, right? Then we have a specificity. That is how effective a classifier identifies negative sample, right? Like positive sample is sensitivity, that is called recall. How effectively a classifier identifies the negative sample, it is called specificity. That is called Tn upon Fp plus Tn. So Tn upon Fp plus Tn. So this is your second class 2 divided by the second row, sum of the second row. Tn upon Fp plus Tn. And my average accuracy or area under curve, that is 1/2 of this recall plus this is specificity, that is sensitivity plus specificity. So area under curve is 1/2 of these two equations. So it is called 1/2 of specificity plus sensitivity or recall. So you have to remember all these terms. You have to remember the formula also. You have to remember the description of each and every term. And these all are used to compare various classifiers. Okay, how you can compare the performance of one classifier with the other? So you can consider accuracy, but accuracy has certain limitation. So that's why we should go for other such kind of measure like precision, recall, or sensitivity, specificity, and you have a average accuracy or area under curve. So see this. This is my confusion matrix, and let us have this kind of value, right? So my confusion matrix is giving 9, 3, 4, and 11. So in exam, I may give like 4 value with a comma separated part, like 9, 3, 4, 11. Then you have to put first two value as the first row and last two value as last row or second row. If I am putting 9 values with a comma, then first 3 value as a first row, second 3 value, that is your second row, and last 3 values as a third row. So try to see. So tell me how many samples have been correctly classified? 9, 3, 4, 11. If you see this, there are two classes, yes and no. So how many samples have been correctly classified? How many are yes to yes and no to no?
20 samples.
20, right? So this cross diagonal, right? So this is my overall correctly classified. So how many samples have been misclassified?
7.
7. So how to calculate accuracy? How do I calculate accuracy?
(20/27).
Yes, right. So put up that value and calculate what is the overall accuracy. What is this value?
Around 74%.
Yeah. So you decide that after decimal point we go for 4 digit, right? So it is 0.7407. All of you, you have to follow common terminology. So if fifth value which is higher than 5, then you have to increase the fourth value, right? Otherwise, if that value, fifth value is lesser than 5, then you have to keep as it is. Chalo, recall. Let us calculate recall. That is TP upon TP plus Fn, right? So you have a blueprint or template side by. That this is given right now in exam. You have to prepare by your own, and this way, if you are going to keep, then you are never going to make any mistake, right? So TP upon TP plus Fn. So first value divided by sum of first row. That is called recall. So TP is how much? True positive 9. 9 upon 9 plus 3, that is 12. So 9 upon 12 is how much? This is called recall. Is it okay? 9 upon 9 plus 3. Then we have a precision. Precision is what? First value divided by sum of first column. That is 9 upon 9 plus 4. TP upon TP plus FP. That is false positive. So 9 upon 9 plus 4, that is 13. So 9 upon 13 is how much? Calculate.
Point 69.
0.6923. And your area under curve, that is 1/2 of your precision plus recall. This is a mistake, right? You see that recall equation. One half of TP upon TP plus Fn and Tn upon Tn plus Fp. So calculate this value, 1/2 of TP upon TP plus Fn. So this is average. We have to make average. That's why 1/2 is there. TP upon TP plus Fn you have already calculated. That is 0.7500. And Tn upon Tn plus Fp. Tn upon Tn plus Fp is the second row. Okay. So 11 upon 11 plus 4, that is 15. So 11 upon 15, that is how much value is there? That you just sum up with this 0.7500 and divide by 1/2. Calculate.
Point 7416.
Okay, now you see the other terms. Okay, actual positive. So please remember the equation for actual positive is this cross diagonal, TP plus Fn. So sorry, TP plus Fn means first row. It is called actual positive. Second row is called actual negative, Fp plus Tn. Okay, so if you make a sum of actual positive, it is called TP plus Fn. It is 9 plus 3, 12. Actual negative is Fp plus Tn, that is 4 plus 11, that is 15. Then predicted positive is Tp plus Fp, that is your first column, that is 9 plus 4, 13. Predicted negative is Fn plus Tn, that is your second column, 3 plus 11, 14. And correct response is your both the classes. Okay, that is 9 plus 11, that is called the correct response. Clear? Chalo, let us have one more confusion matrix, and you can see this value. Actual positive is TP plus Fn, that is your first row. 11 plus 0 is 11. Actual negative is your second row, that is 3 plus 0 is 3. Then predicted positive is your first column, that is 11 plus 3. predicted negative is 0 plus 0 means 0. Correct response is 11 plus 0 means 11. Accuracy is 11 plus 0 upon all, that is 11 plus 3, 14. Recall is TP upon TP plus FN. So TP is 11 and your FN is 11 upon 11 plus 0. 11 divided by 11 is 1. Precision is TP upon TP plus FP, that is 11 upon 11 plus 14, that is 0.7857. And your area under curve, that is 1/2 of your recall, plus Tn upon Tn plus Fp. Tn is 0. 0 divided by anything is anyhow 0. So your 1 plus 0 divided by 2, that is 0.5. So most important question, and this is how you can calculate all the values, right, which are associated with the confusion matrix. This is nothing but the output of any classifier is always in terms of confusion matrix, because here the input and output both are known. Class labels are already known. So we are comparing actual class label what we have supplied in our data set for the training of the classifier, and then we want to see whether these classes have been correctly predicted by the system or not, and how many of them have been not correctly predicted, that is called misclassified. Is it okay? Calculate and tell me if any deviation is there in answer. So in exam, it may be asked like this way, right? This confusion matrix values may be given for 2 cross 2 or 3 cross 3. Okay, if I give 9 values, then you have to prepare 3 cross 3. And then you have to calculate accuracy, precision, recall, sensitivity, specificity, area under curve. Or if I ask like calculate all the terms which are related to confusion matrix, then also you have to calculate all these things. Chalo, now tell me all these values. Chalo, new confusion matrix 0, 11, 2, 25. Right, so if I ask like if the confusion matrix values are 0, 11, 2, 25, calculate all the terms which are related to confusion matrix including accuracy. Then you have to calculate all these things. So chalo, tell me what is actual positive. Someone should tell all the answer and others can validate. Chalo, one by one, who will tell?
Actual positive is 11 and actual negative is 27.
Everybody agrees on this?
Yes.
Who is replying? Anushri?
Yes, sir.
Yeah. Chalo, next value.
2.
Next. Next value.
36.
36. Okay. Correct response. You have to see the cross diagonal. That is 0 plus 25. 25, right? Chalo, accuracy. (25 upon 25 plus 11 plus 2), right?
25 by 37. 38.
38. Yeah, 25 upon 38. Then recall 0 upon anything is 0.
0.
Right? Precision is also 0 because 0 upon anything is 0. And area under curve 1/2 of 0 plus Tn upon Tn plus Fp. That is 2 plus 25. 25 upon 27. And 1/2 of that.
Point 4629.
Okay. Chalo, tell me for this. 9, 3, 4, 11. Last example. Now I think after that you will be confident to attend any of such kind of question.
Twenty by 27.
You tell me the exact value with a decimal point in a 4-digit number.
0.7409.
Chalo, recall. Recall is also called what? Another name of recall is what?
Sensitivity.
Yes. Right? How sensitive classifier is in detecting positive class label, that is called recall. Right? Recall means you are remembering how many of positive. Recall, exactly like the way we recall. Classifier has to recall how many of the labels are positive, like that. So TP upon TP plus Fn. So this general template, right, you can prepare like this so that there will be no confusion in exam also. You can easily answer. So TP upon TP plus Fp, that is 9 upon 9 plus Fn, that is recall. 9 upon 9 plus 3, that is 12. 9 upon 12.
0.75.
Yeah. Precision is TP upon TP plus Fp. So 9 upon 9 plus 4, that is 13. Specificity is your Tn, that is 11, divided by 11 plus 4, that is 15. And 1/2 of your specificity plus your recall, that is sensitivity. This is nothing but my average accuracy. So in previous two example, we haven't calculated specificity, right? If you calculate specificity, 1/2 of your recall or sensitivity and your specificity is nothing but your average accuracy. It is also called AUC, area under curve. So please validate whether the answer is matching or not. So all of we have decided to keep after decimal point 4-digit, right? So everybody has to follow common terminology in exam also. So that your answer, and there is a only single answer for any numerical question, there should be no more than one answer. Agreed? So all of you should not come up with different number. Make sure. So when you work with tool, when you work with Python, right, and when you have a confusion matrix, and if you are going to work with a framework or library, all these values will be automatically calculated. Why? Because this has been implemented as a part of your application program. This all mathematics have been implemented, and that's why you are getting like recall, accuracy, precision, sensitivity, specificity, area under curve. Right? Ultimately, somebody has implemented this as a part of logic, right? Because everywhere there is a mathematics. Without that, right? Same way, you can quickly go through this. 11030. So this is same, I think, right? We have already discussed, but kindly go through it. So now you are aware how to calculate all this, and these all values are very important. So you should not rely only on accuracy, right? But you have to also see that precision, recall, or sensitivity, specificity, accuracy, average accuracy, this all need to be seen. And this is how you can compare the performance of one classifier with the other. These all are the measures by which you can compare the performance of one classifier with the other, right? So if I have a one data set, I want to find out which classifier is better. Then on all these values, I can compare neural network, decision tree, Naive Bayesian, support vector machine, random forest, etc. And I can see where these all values are better, right? So that classifier is better. It means they are more compatible with that kind of data. So this all are the various measures, right, to evaluate the accuracy of the classifier. First is a holdout method, right? So basically, either you can supply 100% record for training, with which you can train your classifier, okay, or you can keep and you can follow holdout method. This is where you have to hold out 1/3 of the record for testing and remaining 2/3 records you should supply for training. So when I say training, first you are constructing a model, and then in a test, during your testing, you are just going to validating whether your training was effective or not, right? So the ideal ratio between training set and testing set is 2/3 and 1/3, that is 66.6 and 33.3%. So if I have a 150 record, right, so 100 record can be supplied for training and remaining 50 records can be supplied for testing. And my expectation is what? All the measure what we have seen related to confusion matrix, there should be no variance in all this with more than 2 to 3%. Otherwise, it is called overfitting, right? So you have to make sure overfitting should not happen. So first is a holdout method. You have to hold out 1/3 of the record for testing or validation, and you have to supply remaining 2/3 of the record for training. So first you have to construct the model with the training data, and then you have to validate that whether the training was effective or not with a testing or validation set. Second technique is a random sampling. Here, see, if you have so many records, so many sample, then it's not possible for me to efficiently derive the accuracy and all related term very fast. So in this case, I should go for random sampling. Okay, so suppose if I want to take the feedback, right now 160 students are there, and I want to take the feedback. So it's not possible for me to take the feedback from all of you individually. So what should I do? I can randomly ask few number like 1, 3, 12, 18, 35, 37, 40, 49, any. Right, and based on that, I am going to collect the feedback, and I am going to believe their feedback is overall feedback of the whole class, which may be correct, which may not be correct. So in a random sampling, I am going to randomly select few sample. So first, again, I have to identify what should be my sample size. Okay, and that depends on your data set size. And I am going to take only randomly few sample, and based on that, I am going to calculate the accuracy, and that accuracy I am going to believe is the overall accuracy of the whole data set, which may be correct, which may not be correct. Then we have a next technique called cross validation. Okay, so here in a cross validation, we have to divide our data set into k fold. So all of you note down one example. Fold means partition. Okay, it is called class also, it is called cluster also. So basically when I talk about fold, don't be confused, it is nothing but a partition. Partition may be class, it may be a cluster, whatever. So total 150 records are there. Chalo, note down all of you. 150 records are there, and I have decided to go for 10 fold. K fold means my value of k is 10. Total 150 records are there, and I have decided to go for 10 partition. That is your k fold, where the value of k is 10. So tell me how many records will be there in each partition or each fold. Total 150 record. This approach is called k-fold cross validation, where k is any numerical value. So here I have kept k equal to 10. So I have decided to divide my data set into 10 partition, 10 classes. So how many numbers or how many number of transaction or number of objects will be there in each partition?
15.
15, right? So what is the first step? See that this is what we have done. Randomly partition the data into k mutually exclusive data subset, right? So this is what we have done with a approximate equal size. So why they have written this approximate equal size? Because if you have a 149, then what will happen? With the possible exception of the last partition. Okay, so all partition have 15 except the last one where you have a 14, right? Because you cannot exactly divide them if the number is not divisible by 0. That is, your number is divisible by any of this value and your overall answer is 0. So now what we have to do? Out of 10 partition, I am going to take first 9 partition. So how many records will be there in first 9 partition total?
$135.
135. Okay, so this 135 I am going to supply for training, and the last partition, that is the 10th partition, that is 15th record, I am going to supply for testing. Okay, so I am going to observe the accuracy here, and I am expecting that the variance should not be there between training set and testing set. This is my first iteration. Okay, now in second iteration, what I am going to do? One partition which out of all which I have considered for training, I have to drop it for testing, and that testing partition I have to include in training. So this is called cross validation. Okay, so let us consider that second partition I am leaving for testing, and partition number 1, 3, 4, 5 up to 10 I am considering for training. So my sample size is same, 135 and 15. This I have to repeat 10 times, right? So every time in one iteration, one partition of training I have to left for testing, and testing partition I have to include in a training. And this I have to iterate until all training partition can become a part of testing, right? So it is called cross validation. So 10 times I am going to repeat, and then I am going to take the average accuracy of all 10 iteration. This is what is my overall accuracy of the classifier. Is it okay? Do you understand what do you mean by cross validation? K-fold cross validation or N-fold cross validation. First of all, you have to see how many records are there in your data set, how many images are there, how many videos are there, whatever. Then you have to decide the size of your partition, means how many partition in which you have to divide your data set, 5, 10, 15, whatever. And then what you have to do? K minus 1 should be supplied for training and last should be supplied for testing. And this you have to cross validate and iterate for 10 times or whatever number of fold times until all partition of your testing can become part of training. And every time you have to exclude one partition of training for the testing. So this is called cross validation. And then every time you have to observe the accuracy, and then you have to take the average accuracy of the classifier. So can anyone tell what we want to do with this? What do you mean by this cross validation? Do you understand what I am saying? So if I am removing 15 record, okay, every time, and if I am just keeping the remaining record 135, then what is the overall performance of the classifier? In which partition it gives the worst result, in which partition it will give the best result, and then overall my overall average result. This is what we are achieving with a cross validation. Exact similar technique, but there is some deviation for that, is called leave one out. Note down, leave one out. So only one fundamental difference between cross validation and leave one out. In leave one out, after every iteration, the partition which we have kept for testing you have to remove, right? Which is not going to be a part of training set, right? Like unlike what we are doing in terms of your K-fold cross validation. So same example, 150 record, I have decided to divide them into 10 partitions. So K equal to 10, that is your 10 fold. Every fold is going to have 15 records. So in a first iteration, I am going to supply 9 partition for training, 1 for testing, right? And I am going to observe the accuracy of both training set and testing set. Now in a second iteration, I have to remove the last partition which I have considered for testing. So how many partitions are remaining now? How many partitions are left now? I have removed the last one. 10th one. How many partitions are remaining now? Leave one out. In every iteration, you have to leave last partition out. I have a total 10 partition. Okay, in first iteration, I have kept 9 partition for training and last for testing. In the second iteration, I have removed the partition which I have kept for testing. Tell me how many partitions are left now?
Total
9.
9. So now what should I do? Out of 9, first 8 I am going to keep for training. Last I am going to keep for testing. Okay, again I am going to observe the accuracy for both training and testing set. Now what I am going to do? I am going to remove the testing partition again. So how many will be left in my third iteration?
8.
8. Out of that I am going to take 7 for training, 1 for testing. So now tell me difference between k-fold cross validation and leave one out. In k-fold cross validation, every time all 10 partitions are there in terms of training set and testing set. You are not removing any of the partition. While in leave one out, in every iteration you are removing the last partition which you have kept for testing. Right? And you are just again dividing the remaining partition among the training and testing, and then you are observing the accuracy. Fine. So this is all are very important question. This all are the classifier performance evaluation technique. Most important question again from your exam point of view. Right? Like holdout method, random sampling, stratified sampling. Okay. Strata means class again. So difference between random sampling and stratified sampling is what? Suppose if I have decided to go for 10 students feedback from your class. And if I am going to go for random sampling, there may be 6 boys for 4 girls. There may be all boys. There may be all girls. There may be 7 girls, 3 boys. There is no equal partition. But if I go for stratified partition, random sampling, then I am going to divide my data into strata. Strata means with respect to some output variable, for example, gender. So there will be 2 classes, male and female. And now I have decided my sample size is 10. And it is divided into 2 classes, so 10 divided by 2. So I am going to take exactly 5 male and 5 female. While in case of random sampling, there is no guarantee that exactly same number of sample will be there from same number of classes. That is called strata. So fold, strata, class, cluster, this all have a same meaning. They all are basically various terms used for partition. Right?
Hello, sir.
Yeah.
How can question be asked from this topic?
Madam, I'll show you with a orange canvas or any other tool or Python, right? Like all this, what we have discussed is an automation which we already have achieved. And when you write the framework in Python, okay, whenever you are going to work with a library, this all values will automatically come. But what is the mathematics behind that, like precision, recall, accuracy, this holdout method, random sampling, cross validation, stratified cross validation, right? So you have to basically divide your data into fold, and you have to ensure that your same number of samples should be there. For example, it is your stratified cross validation. So in exam, I have already said confusion matrix and all related term. You may be given directly like this all are the confusion matrix value, and you calculate accuracy, precision, recall, etc. Or you may be asked to calculate all the terms which are related to confusion matrix. Then you are already aware, sensitivity, specificity, area under curve, accuracy, right? Precision, and which are the classifier performance evaluation technique. Then it is holdout method, stratified sampling, random sampling, cross validation, leave one out.
Okay, sir. Thank you.
So let me show you, okay, without going any further, I'll show you with, we have already seen, but I believe you right now can't recall. So let me show you. So what we have discussed, I'll show you the automation so that you will understand what I mean to say. Whether you have a structured data or unstructured data, right? You have to justify or you have to select which classifier is better for the problem at your hand, right? Right now, the data set with which you are dealing. So I am taking one file right now, like iris.tab, okay? And I am having test and score. So this test and score will give you all this, right? So here the logic has been implemented, what we have seen mathematically, and then we have a confusion matrix. So this all values have been calculated from confusion matrix. So what is your classifier here? Suppose I want to take Naive Bayesian, right? I want to take neural network. I want to take decision tree, right? So I am supplying this data to all my classifier, and so here if you see, right, this is area under curve, classification accuracy, false measure, precision and recall. So note down the equation to calculate F1 score. This is called false measure or F1 score, right? So area under curve, you are already aware. CA means classification accuracy or accuracy, you are already aware. You are aware about precision, you are aware about recall, right? So write down the equation to calculate F1 score. It is 2 into precision into recall, 2 separate, right? Precision into recall upon precision plus recall. And then you have to overall multiply by 2. So let me show you if it is there.
Sir, can you repeat formula?
Yeah, I'll show you here. F1 score. This is what? 2 into precision into recall upon precision plus recall. It is called harmonic mean. Right? So you are aware how to calculate precision and recall. You have to just put up this value in this equation. So precision into recall upon precision plus recall, and then you have to multiply overall value by 2. That's it. Okay. So this is your F1 score. So this is what all automation of what we have discussed, right? So see that for right now you done all this manually. Here this has been implemented in this framework or library, so you can get all the value. Now here you see on the left hand side cross validation. How many fold? 3, 5. So if I make 5, you see runtime it has changed all the value. Okay, random sampling. You see how many values I want right now? 66%, 30%, 50%, 20%. So if I am going to calculate, you see right now runtime it will do. Leave one out, right? Then you have a test on training data. Try to see. So this is what we were talking about, 2/3 and 1/3. This is called holdout method. So this all are the classifier performance evaluation technique, left hand side. And this all is my confusion matrix related to that, all these terms, right? What we have learned today, how to calculate. So this is what we were talking about. Cross validation means you have divided your data set into 5 partition right now, right? You can go for 10 partition also, and you can see that you will have a different answer. Right, so here I have click on stratified, right? Stratified means equally it will take from each strata. So there are three different class label. All of you are aware about Iris setosa, versicolor and virginica. So if I decided this stratified means it will take exactly same number of value from all the class. But if I remove this, it will not take same number of value from each class. So this is my classification performance evaluation technique, and this is all terms which are related to confusion matrix. Right. So this is what is my confusion matrix. So now instead of 2 cross 2, it is 3 cross 3. This is my actual. See that? This is my predicted. So whether it is 2 cross 2 or 3 cross 3, in general, we have a n cross n. So you have to remember this n cross n. This is my n cross n. So whether it is 2 cross 2 or 3 cross 3, right? You have actual and predicted, and you can have as many classes. These are going to become row. And the same way you have an equal number of classes in terms of column, and how many values have been. So it is 2 positive 1, 2 positive 2, 2 positive 3. False negative, right? False negative 1 3 means it is combination of 1 and 3. Same way 2 3, same way like that. So this is your confusion matrix for several class problem. It is called n cross n, right? You can have 5, then it is 5 cross 5, 6 classes, then you have a 6 crosses. So here, can you not calculate all the values? So tell me how many values have been misclassified here. From this confusion matrix, tell me how many values have been misclassified now.
16.
Right? So whether it is 2 cross 2 or 3 cross 3, right? You can easily find out how many values have been misclassified. So if you have to calculate accuracy, tell me how are you going to calculate this value divided by total, right? So 50 plus 41 plus 43 divided by all, that is your 150, is nothing but my overall accuracy of the classifier. Right, same way other terms you can calculate: precision, recall, sensitivity, specificity. Right, this is for second classifier, how many values have been misclassified, and this is for your class 3. And here you can click on select misclassified, and then last time we have seen, if you remember, let us connect this with a scatter plot. Right, so these all are my misclassified values. You see, these all samples have been misclassified. There are 3 different class and there are 3 different color. So same way you can change the classifier and you can see the misclassified values. See this? Calculate this total number of count and match with your misclassified sample. You see, blue is a class 1. Red is a class 2 and this is class 3. So count how many total circles are there. 2, 3, 4, 5, 3, 6, 7, 10, 12, 12 plus 3, 15, 18, 20. So if you just go to your confusion matrix and see how many samples have been misclassified. See, 1 plus 13 plus 8. And when you click here, you will get the whole record. Okay, like suppose I want to see this value, like what is this sample which is misclassified. You have to just select and connect with a data table. You can see whole this record which is misclassified. You will get whole record value which is misclassified. So is it okay? So when you work with scikit-learn in a Python as a library, it will do all this. What I am right now using, currently I have used is scikit-learn. All your machine learning functionalities will be provided by scikit-learn. Right? So this all, when you use the framework, this all value will come. So you as an engineer should be aware there is a mathematics behind that, and there is a full concept behind that. So what is cross validation? What is leave one out? What is random sampling? What is holdout method? These all are the classifier performance evaluation technique. And then which are the terms which are related with confusion metrics like recall or specificity, sensitivity, area under curve, F1 score, accuracy. So how these values are calculated and with respect to what? With respect to all classifier performance evaluation technique. Whether it's a cross validation and a k-fold, or it is leave one out or random sampling or holdout method. Bolo, any question? Is it okay?
Yes, sir.
Any other students have any doubt or question? Feel free to ask question.
No doubt, sir.
So please remember, this is the most important part, right? You have to work with unstructured data, means you are going to work on a deep learning also. So this analytics part is always handled by machine learning, including inside our data science also. So when we talk about machine learning or deep learning, means when you work with images or video or audio, then of course you have to go for convolution neural network and all, but output is always in terms of confusion metrics. So precision, recall, sensitivity, specificity, area under curve or average accuracy or F1 score, this all will always comes in the picture. You should not only rely on accuracy, right? And you should be also familiar about cross validation, leave one out, holdout method, random sampling, stratified sampling. So if you have structured data, you have to work with machine learning. If you have unstructured data, you should go for deep learning or deep neural network architecture like CNN, RNN, LSTM, restricted Boltzmann machine, RBF, right? GAN, generative adversarial network, self-supervised learning, RNTN. So most important questions from your exam point of view, okay, you may be given confusion matrix value, maybe 2x2 or 3x3 or whatever. You have to calculate all these values, or you may be asked to give the note, or you may be asked a question related to classifier performance evaluation technique, whatever we have discussed. Fine, so we'll continue with this and we'll see more important concepts which are practically required in industry, which are required to be studied, not from theory point of view, right? My role is different in this subject. I am going to give you all this hands-on and the experience and mathematics and statistics behind the actual concept which are used in terms of practical or skill. And Parth and other teachers will cover the theory. Fine. Shall we stop then if you don't have any question?
Sir, can you share this material?
Yeah, of course, why not? I am going to share everything with you, right? All of you, always. So I'll share all this PPT and everything. No worries.